Good morning, all of you. Today also I will explain some questions, some problems based on the photoelectric effect. Photoelectric effect. Please note down. In photoelectric experiment, the slope of the cutoff voltage versus frequency of incident light is found to be 4.12 into 10 to the power of minus 15. That value is 4.12 into 10 to the power minus 15. Just imagine whatever this units is equal here. Whatever that units. After my question, please think about this units. 4.12 into 10 to the power minus 15. Calculate the value of Planck's constant. This cutoff voltage value is taken on y-axis and again frequency on x-axis here. Sum is completed. What about the units? The slope of the cutoff voltage versus frequency of incident light is found to be. That value is equal to 4.12 into 10 to the power minus 15. Now whatever the slope is equal here, this slope is equal to. So we got the value is equal to h by e. Is it clear? Again, from this graph, what is slope is equal, what is that equation here? Tan theta is equal here. So tan theta is equal, opposite side is equal, this one is equal to V naught. Again, change in potential, this is equal to V naught. Again, this one is equal to nu. So V naught by nu. So what about this units is equal, tan theta is equal to V naught by nu. So V naught is equal to say potential, this one is equal to volt. Again, nu is equal to frequency, this is equal to per second. So 1 by second, this value is equal to volt to second. The units of the slope is equal to volt to second. Please note this units also here. So volt to second, not volt per second. The units of the slope of the V naught and nu. V naught and nu graph is equal here. So 4.12 into 10 to the power of minus 15 volt to second. So now in this question, so what is the Planck's constant is equal? Planck's constant is equal to. What is the equation here? So one slope is equal, the slope is equal to here the h by e. This is equal to the first equation. So our second one is equal, slope is equal to tan theta. So which value is equal to V naught by nu. From these two equations here. So equation 1 is equal to say equation 2. Equation 1 is equal to equation 2. So h by e is equal to V naught by nu. So V naught by nu. So what is the V naught by nu is equal to how much is given here? So this value is equal to slope is equal to given. This value is equal to 4.12 into. So 4.12 into 10 to the power of minus 15. So h is equal to say 4.12 into 10 to the power of minus 15 into e. So where E is equal to 1.6 into 10 to the power of minus 19. So 4.12 into 10 to the power of minus 15. So E value is equal to 1.6 into 10 to the power of minus 19. So find out this value is equal to 6.65 some value into 10 to the power of minus 15 minus 10 minus 34 minus 34. So this answer is equal to here 6.592 into 10 to the power of minus 34 minus 34. That units is equal to joules second. So according to this graph, we found the Planck's constant of the Planck's constant. This value is equal to 6.592 into 10 to the power of minus 34 joule second. Next one. Next one. In a photoelectric experiment, the frequency of incident light is plotted against the stopping potential V naught. You have to write complete name also, stopping potential V naught. Find the work function of photoelectric surface in the bracket. E is equals electronic charge. Same as previous graph. Write the first option. So OB into E, units in electron volt. Second option, so OB in volt. Third one is equal to OA in electron volt. Fourth one is equal to the slope of the line AB. This is a previous NEET question. I given this application, I told this concept also. In the photoelectric effect, the incident light frequency, and again next one is equal to stopping potential. V naught is equal to stopping potential. So V naught value is taken on y-axis here, nu is equals on x-axis. Okay, same conditions also here. Okay, now again, so what is the work function of this metal surface is equal to? So what is the work function of this metal surface is equal to? So again, in last class I given these conditions also here. So this one is equal to slope. First point is equal to slope. So what is slope is equal to how much? Well, this is equals h by E. This value should remain constant for all metal surface. Okay. What is the slope is equal to here? The slope is equal to h by E. Second one is equal to x-intercept is equal to OA. So what is the OA is equal to how much? This is equal to say, so nu naught. So where nu naught is equal to threshold frequency. Again, third one is equal to y-intercept is equal to OB. OB is equal to what is the value? Just imagine OB is equal here. So this is equal to h nu naught by E. Is it given in last class here? So this OB is equal to y-intercept is equal to h nu naught by E. So this one is equal to the y-intercept OB is equal to h nu naught by E. So in this question, h nu naught is equal to work function of given metal only. So h nu naught is equal to work function of given metal. So hence OB is equal to W naught by E. So what is the W naught is equal? What is that equation? W naught is equal to OB into E. Check that options here. So first option is equal to OB into E. So this work function units also electron volt. Yes, please note down. This is a previous NEET question. Just only will get answer within 1 second if you know this application. Compulsory how to practice these three conditions. One is equal to slope, second one is equal to OA, third one is equal to OB. So where OA is equal to x-intercept, OB is equal to y-intercept. If you know this concept, this application, the sum is very simple and very easy also. Simple logic only here. This y-intercept is equal to OB is equal to h nu naught by E. So this value is equal to h nu naught by E. So here h nu naught is equal to work function only here. So W naught by E. So what is the work function is equal to? So W naught is equal to OB into E. Okay, next one. This anode potential value is taken on x-axis and the intensity of incident light value is taken on y-axis. So this one is equal to A, this is equal to B, C. Draw this graph. Again, write the question also. In figure shows the variation of photoelectric current I and anode potential V for the photosensitive surface for three different radiations radiations, let IA, comma, IB and IC are the intensities and FA, comma, FB and FC are the frequencies for the A, B and C respectively. So respectively, then where the first option, IA is not equal to IB, FB is equal to FC. Second one is equal to IB is equal to say IC, FA is not equal to FB. Again, third one is equal to IA is not equal to IC. Again, FB is not equal to FC. Fourth option, so IA is equal to say IC, so FB is equal to FC. This is the previous mains question. If you know this photoelectric emission concept, the sum is very simple. You will get answer within 1 second only here. So this is equal to photoelectric current I values on y-axis, and again anode potential on x-axis one here. So this is equal to photoelectric current on y-axis. Here the three light radiations are given. One is equal to A, second one is equal to B, third one is equal to C. Clear this one here, A, B and C one here. So whatever this one is equal, this is the intensity of A. So one is equal intensity of A. This one is equal intensity of B. Next one intensity of C. Now just imagine here, among three light radiations, which are the intensity should remain the same here. See this question here, B and C should remain the same one here. So this is IB is equals IC, IB is equals IC. This IB and IC value is more than A or less than A one here. Since here this value is equal IB and IC more than A only. So IA is less than of IB and IC. Is it clear here? Okay. I told this is equal second graph of this photoelectric effect only here. So whenever here this saturation photoelectric current depends upon the intensity of incidental light. So whenever intensity is increased here, this photoelectric current is also increased only. So intensity of light is increased, the photoelectric current is also increased. Same, this also here this IB and IC both are same. This value is more than IA. Stopping potential is equal to V0, okay? Again, so what is the condition here? Stopping potential of, so V0 to A, so which is equal V0 A. Again, next one is equal stopping potential of, second one is equal to B. Again, third one is equal to C only here. So which value should remain the same here? So A and B should remain the same only here. So this A and B should remain, so V0 A is equal to V0 A is equal to, so V0 B. Again, next to V0 C value, is it less than or more than is equal here? So this is equal to V0, this is equal to, which value is more here? This is equal to A and B. So A and B, this one is equal to C. So VC is more than of, so VA and again VB. Okay, same this also here so FA, FB, FC. Same this also frequency of the A is equal to B, and again here this is less than of FC only. Okay, this is the conditions only. If you know this condition here, the sum again simple also here. So what the first condition is equal here, IC value is more, and which is equal to IB. So again, IA is less than IB and IC. Okay, this is clear this here. The intensity of light is increased, the photoelectric current is also increased only. So this one is equal to second law of the photoelectric effect. Okay. Again, next one. Same again here, this is equal to stopping potential, negative potential only. It depends upon the frequency. So V0 A is equal to V0 B. V0 A is equal to V0 B. So again, which value again? V0 C value is more than this one. Same as frequency only. Now check the options here. It's clear, third option over here. So IA is not equal to IC, FB is not equal to FC only. So this is equal to correct option here, this third option here. So this previous mains question. Okay, whenever you have to practice concept orientation, so maximum sums very simple. Don't by heart that equations. Please take third option. So what is the condition means here? So IA is less than IB is equal to IC. The intensity of the C and B should remain the same according to this graph, and which value is more than of A only. And again, next one, this stopping potential of A and B should remain the same. A and B should remain the same. So which value? Next one is equal to C stopping potential is more of this A and B. So hence again same as again FA is equal to FB, which again less than of FC. Again, next question. Next one. Find the maximum velocity of an electron emitted by light of wavelength lambda. Wavelength symbol is a lambda. Incident on the metal surface of work function pi. Now W naught work function pi. So now what is the maximum velocity of the electrons emitted by the light of wavelength is equal to lambda is incident on the metal surface. This work function of the metal surface is equal to pi. What is the value of the velocity is equal to? What is the maximum velocity is equal to? What is the maximum velocity of kinetic and maximum velocity of the electron equation? The energy E is equal to say W naught plus Ke max. So this is one of the basic and main equation. This energy E is equal to hc by lambda. So why you are taking hc by lambda? Since here the incident light wavelength is given here. So incident wavelength is equal to lambda whole. That's why you have to take hc by lambda. Again next W naught is equal to this value is equal to pi. Again Ke max is equal to half mv square. So from this equation you have to find out V value. So half mv square. So V is equal to maximum velocity. So what is that equation? Half mv maximum square is equal to say, so hc by lambda minus pi. Clear this equation? One simple equation, hc by lambda is equal to pi plus half mv maximum square. So half mv maximum square is equal to hc by lambda minus pi. So this V maximum square is equal to 1 by 2m. What happens? This value is equal here. So this one is equal to 2 by m into hc by lambda minus pi. Again you can do this LCM also. So this is equal to 2 by m into hc minus lambda into pi by lambda. Okay, this one is equal to V maximum square, or V max is equal to square root of 2 by m into hc by lambda, hc minus lambda pi by lambda. This is a maximum velocity of the photoelectrons when work function is equal to pi is given. So V max is equal to square root of 2 by m into hc minus lambda pi by lambda. Next sum. Next one. Note. Two identical frequencies, light of frequencies, F1 and F2, F1 and F2. If the velocity of photoelectrons coming out respectively V1 and V2, then where the first option, V1 square minus V2 square is equal to, this is equal to say 2h by m into F1 minus F2. First option. So V1 square minus V2 square is equal to 2h by m into F1 minus F2. Second one. So V1 plus V2 is equal to, V1 plus V2 is equal to, so 2h by m. So F1 plus F2 whole to the power of 1 by 2. Again, third option. So V1 square plus V2 square, which is equal to 2h by m. So F1 plus F2 whole square. Again, fourth option. So V1 minus V2 is equal to, V1 minus V2 is equal to, so 2h by m into, so F1 minus F2. Four options are given. Two identical photocathodes receives. So two identical photocathodes receives light of frequencies. So first two frequencies is equals to F1, second one is equals to F2. Instead of nu1 and nu2, that frequency symbols are given F1 and F2. And again, the velocity of the photoelectron coming out respectively, the velocities are given V1 and V2. Among these four options, which one is the correct one here? First option. So V1 square minus V2 square is equal to 2h by m into F1 minus F2. So how these equations are? First option here. Equation energy, same equation here. The basic equation energy E is equal to. So energy is equal to W naught plus Ke max. Same equation for all questions on here. So E is equal to W naught plus Ke max. So what is E is equal to here? So in this question here, the two light waves of frequencies are given. So frequency given, what is that equation? Energy is h nu. So this is equals h into nu, or this is h into f. So which value is equals to W naught. Work function is equals to W naught. And this one is equals to half m v square. So half m v maximum square. This kinetic energy maximum is equal, half m v maximum square. So for all options here, so left side is equal to velocity is one here. So now we have to write this velocity equation. What is velocity equation here? So half m v square is equal to half m v maximum square is equal to. So what is that equation here? So h nu minus W naught. H nu minus W naught. First point. So this one is equals to half m into v maximum square means v1 square. First case. Since here the velocity of the first frequency of light is equals to v1. So now what is that equation here? So square. So which is equal to, this one is equal to h into f1. The incident light frequency is equals to f1. Again minus W naught. So this is equals equation 1, first point. Second one is equal here. So half m v2 square, So which is equal to h into f2. So minus w naught. So this is equals equation 2. Check that options here. For all options here, this w naught value is not there. Take maybe 1/4 one. W naught is there. So now again equation 1, equation 2. So what about this one here? By adding, subtracting here. So equation 1 minus equation 2 is equal to. So equation 1 minus equation 2, which implies, yes, do the sum. Simple question here. So equation 1 minus equation 2, which implies, so equation 1 is equal to half m into v1 square. So half m is equal to common here, v1 square minus v2 square, simple equation. So which is equal to here, which is equal to hf1. So hf1 minus w naught, this is equal to first equation, again minus of second equation, so hf2 minus w naught. So here the minus w naught plus w naught is cancelled only. So in this equation, h is equal to common. So half m into v1 square minus v2 square is equal to. So h is a common. So f1 minus f2. So what is the v1 square minus v2 square? What is that equation? So this is equal to 2h by m into, so f1 minus f2. So this is the one equation. Which is the correct one option here? First option. So v1 square minus v2 square is equal to v1 square minus v2 square is equal to 2h by m into f1 minus f2. So v1 square minus v2 square is equal to 2h by m into f1 minus f2. Again, one application. This is our metal surface. Incident light is equal to say nu. The work function of the metal surface is equal to say W or W naught. The kinetic energy is equal to say K, or this is equal to say KE1. The kinetic energy of the photons is equal to say KE1. Suppose here the incident light radiation is made of n times only here. The frequency is made by n times, frequency by n times. So what about kinetic energy is equal? Is it also increased n times, or maybe again double or triple is equal here? Just imagine the frequency of incident light is equal to n. Again, this kinetic energy of this photoelectrons is equal to Ke1. The kinetic energy of the photoelectrons is equal to Ke1. Suppose if the intensity of this frequency of the incident light is made by the n times only. Second case is equal to n into nu. Then what about this kinetic energy is equal to? It will become n times or n square times here. Just imagine, what about frequency changes, what about this kinetic energy changes? No. A monochromatic radiation of frequency nu is incident on the metal surface frequency nu is incident on the metal surface of so work function W. And kinetic energy of and Ke is the kinetic energy of photoelectrons if nu is increased by n times, then the kinetic energy also maximum. The kinetic energy also more than dash times. How many times? N times, n square times, or 1 by n times. Just imagine this question once again. So whenever here the incident light is increased by n times. So whatever is the kinetic energy increase or becomes more than how many times is equal here? How many times? So this one is equals incident light frequency nu. Incident light frequency is equals to nu, and again work function is equals to W naught. Kinetic energy is equals to Ke. Second condition. This frequency is equals to n times. So this is equals to n into nu. Same, this work function should remain same. Since here same metal only here. This work function depends upon the nature of the metal only. Same metal means what happens? Same again W naught also. Again whatever is kinetic energy Ke dash is equal to how much value? N times. So this kinetic energy Ke, what is that equation here? Energy E is equal to W naught plus Ke max. W naught plus Ke max. Here this Ke max is equal to E minus W naught. Here E is equal to H nu. So this one is equal to kinetic energy is equal to Ke. So Ke1. So Ke1 is equal to E minus E is equal to H nu. Again minus W naught. So this is equal to equation 1. Clear? So Ke1, first case is equal Ke1 is equal to H nu minus W naught. Again second case, same equation, second case, this kinetic energy is increased how many times here? This is equal to E is equal to H nu is equal to W naught plus Ke max, Ke maximum to Ke maximum 2. Ke max 2. So what is the Ke max 2 equation here? Ke maximum 2 is equal to, so H nu what is equal? This is equal n times only here. So this is equal to n into H nu minus W naught. So why we take n value means here, since here this frequency is increased by how many times? The frequency is increased by n times only. So whenever incident light frequency is increased by n times. So what is the equation here? This is equal n into H nu. So n into H nu again minus W naught. So here n is not there, so here possibly this is equal to equation 1 here, or this is equal to n into h nu, second case. So n into h nu is equal to w naught plus Ke maximum 2, or Ke maximum 2 is equal to n into h nu minus w naught. So this one is equal to equation, this is equal to equation 2. So now tell me here, so what is the relation between the equation 1 and equation 2? So equation 1 is equal to Ke maximum 1 is h nu again minus w naught, okay? So now this equation is multiplied with n times only. Suppose Ke1 is equal to K1, so this is equal to n into Ke1, or simply n into K1. This kinetic energy is equal to K1. So n into Ke1, which is equal to, so n into h nu minus n into w naught. So this is equal to one more equation, okay? So now this equation is equal to 1, so you have to remove this equation 1, okay? No need, okay? So simply here the equation 2 is equal to n into h nu only. Again this is equal again, same this is equal again, you should multiply with n only. So now again this is equal, equation 1 is equal to n into Ke1, so which is equal to n into h nu minus n into w naught. Again this is equal to what is that equation here? Ke maximum 2 is equal to nh nu minus w naught. So equation 2 minus equation 1, which implies so equation 2 minus equation 1, which implies so Ke maximum 2, or simply this is equal to Ke dash, okay? So Ke maximum 2 is equal again. So minus equation 1 is equal to n into Ke maximum 1, simply n into Ke. So which is equal to, this is equal to, so equation 2 is equal to n into h nu, so minus w naught. Minus of, so what is equation 1 is equal to n into h nu, so minus w naught, okay? So n into h nu minus n into w naught. So now tell me any cancellation here, so this is equal to nh nu, again this also minus nh nu, so this one is equal to cancel. So the remaining equation here, Ke maximum 2 is equal, Ke maximum 2 is equal, which is equal to, so n into Ke1, again next one, this one is equal to here the minus w naught, this is equal to again plus. So this one is equal to n into w naught minus w naught. So this is equal to Ke maximum is equal to Ke dash. Okay, dash. Okay, Ke maximum 2 is Ke dash. So which is equal here n into Ke1. Again plus w naught is equal to common n minus 1. So what the question is equal here, this kinetic energy is also becomes more than how many times here? So how much value is equal here? This Ke dash is also here, how many times? This is n times 1 here. So Ke dash is equal to n into Ke1. This is more than of this one here. Suppose this one value is equal to 8, 8 is equal to again of 6 plus 2 one here. So what happens here? This 8 value is more than of 6 one here. So 8 value is equal to more than of 6, since 6 plus 2 is equal to 8. Same this also here, the Ke dash is equal to n into Ke1 plus this value one here. So what happens here? Ke dash is greater than of n into Ke1. So that means here the kinetic energy is also becomes more than of how many times here? This is equal to n times. So n times, very important application. So whenever the frequency of incidental light is increased by n times only, so hence the kinetic energy is also again more than of n times. Increased, it becomes again more than n times. So Ke dash is equal to n into Ke. Next coming Sunday syllabus up to Einstein photoelectric equation.